Design patterns are one of my favorite topics in software development, but it's important to not get overwhelmed because depending on your source, there are 22 to 40 to maybe even more design patterns. And they're things that take a bit of time to master, so you don't want to master all of them at once. Now, in a previous video, I've shown through example 4 of my favorite design patterns: factory, command, template method, and singleton. And those are ones that I did a code example to get immersed in, and hopefully that will give you something to really see the value of design patterns. So in this video, I want to explore several of the other design patterns that are available and talk about some uses that I've seen for them before. We know there are 3 categories of design patterns: behavioral, structural, and creational. Let's start by taking a look at some behavioral patterns. Observer is a well-known behavioral pattern where effectively you have something who's publishing events or data and something that's subscribing to those events or data. Think about a stock ticker application like your online broker. You might have purchased a stock in some company, and when you open your application, you can see the price update in near real time as that price changes. So the publisher of the data is probably some market-making system that's dealing with these trades that provides that to your broker, and then your broker publishes it to your application. The subscriber is you and everybody else who is a customer of your broker who owns the stock, who's looking at the application right now and seeing these real-time updates. So it's important that we can subscribe to what we want to without having to subscribe to everything. We don't want to get updates on every single asset that's listed on the New York Stock Exchange and the NASDAQ, but only those that we actually own and that we actually care about. So observer pattern, notify objects when something changes, and we subscribe to that. We get updates when that changes. Now, I mentioned a stock application, and actually there is a well-known observer pattern that we use quite frequently in mobile development. And in mobile development, oftentimes we have this concept of live data. Live data means a stream of data that changes or a stream of events that gets published. And we want to observe that stream. So this is a slide that I use in my programming mobile devices class when I'm talking about GPS updates that we receive on Android. I'm going to fast forward through a few steps here. We see that GPS locations are getting fired into this thing called location live data. Location live data is effectively the publisher of the data. So what we'll see is that it has an event, and then anything that is selected to observe on that data is going to receive that event. Here we have a couple of screens in an Android application, but over here we also have a unit test that's testing the data that comes down. Now, nice thing about being an observer is if you wish, you can pause notifications. You can say, okay, I don't need to get notified about this anymore. And then when the publisher publishes the next update, it's only going to go to those who chose to continue to observe, as we see here. But the one that paused is not going to get that update. So publish, subscribe, we can have a publisher, we can have subscribers, and as they wish, those subscribers can choose to unsubscribe or pause notifications and then turn them back on. This design pattern has become enormously popular lately with mobile devices and with real-time data. So if we roll back to when I was in college, that idea that you could turn on a computer and open a monitor and things would update automatically was not something we were used to. You had to press a refresh button or close the app and restart. But if you think about applications today, this concept of observable data is quite common. I mentioned stock tickers, I mentioned Android and iOS applications, but think also about Facebook. What happens when you go to Facebook and you leave the screen up for a little bit? You know, it updates as your friends are posting messages. So they're posting messages to Facebook, and Facebook is publishing those messages to observers. And in the land of Facebook, who are observers? Observers are your friends. So you see that Facebook really is just a humongous observer pattern, as most of the social networks are. And frankly, right now, a lot of the apps are that way too. With chain of responsibility, we have a request and we have a series of handlers or value-added steps that can process the request. So typically they'll go in a certain order. A handler will receive this request and decide, this is a valid request, I'm going to handle it, and then pass it on to the next handler. or this is a valid request but I don't need to handle it, I'm going to go ahead and pass it on to the next handler, or this is not a valid request, so I'm going to essentially terminate the request and I'm not going to pass it on to the next handler. So I can think of two good examples of chain of responsibility. One I remember from my days in point of sale, and I'll show that in just a moment, and that's the steps that happen when a point of sale server is processing a transaction. The other one, frankly, is CI/CD. If you've ever worked with CI/CD and you've written a YAML file, what is that? It's a series of steps that happen after you commit and push code, usually to version control. So the first thing is it's going to compile. And if it doesn't compile, why even bother with the other steps? But if it does compile, let's pass it on to the test phase. And if the test pass, well, then we have the option to deploy, so on and so forth. So both of these are essentially chain of responsibility. Now, here's the example that I have from when I worked in point of sale, and this is commonly how point of sale systems work. So we have a store server or a central server, and then we have a series of point of sale devices or cash registers. And a point of sale is typically consuming prices, products, and promotions, and then outputting transactions. Now, grabbing that transaction is very important because the retailer has a lot of interest in the transaction, as does the consumer. So we start with this transaction at the point of sale, we total it out, we tender it out, and then it posts to our point of sale server. Now, our point of sale server, which could be handling a lot of transactions at once, is going to pass this off to a chain of responsibility. First of all, let's add the transaction to the database so that we can do transaction lookup, if the customer is missing a receipt or something like that, or we can store and forward, whatever we're going to do there. Then we're going to invalidate one-time use coupons and say, okay, these have been used, can't be redeemed again. Then we'll update our loyalty points. We'll probably update payment methods, things like that. And if the user chooses, we can generate an e-receipt. Or if the user doesn't choose, we simply skip that step. So the series of value-added events that occur after we've posted a transaction. And as I mentioned, the other example is a config.yaml. Here's one I pulled from one of my GitHub repositories. You see we have a series of steps here: checkout, restore cache, change permissions, download dependencies, save cache, run test, store artifacts. If something went wrong early on, we wouldn't want to do the further down steps. So that's where chain of responsibility works out really well, because each of these steps can decide whether to abort the process or continue the process. Iterator is an interesting one because it tends to be one that we use but don't necessarily implement because it's already been implemented for us. Iterator makes the most sense if you understand in the Java programming language, the Java collections framework, or in C#, their collection framework, whatever programming language you're using, their collections framework. So we typically start with an array list, which is just, okay, here's everything in an order. Then we learn about hash maps, where we can order things based on an inherent key that can be computed, which gives us really good algorithm growth performance, which we'll talk about in a separate video. But then we have all kinds of other collections too. We have queue, priority queue, stack, linked list, tree map, sorted tree map, on and on and on and on and on. And these are not necessarily linear. But if we want to shake hands with every item in that collection, we want to loop over them, typically with a for each loop. And so the Iterator interface gives us a for each method, and then all of the implementing classes, which are all of those collections, have to provide a implementation for that for each method. So if we take a look at the documentation here, this I pulled straight from the Oracle documentation on Java. And this is an interface called Iterable. And Iterable is implemented by all of these collections down here. There are quite a few. And you see here that Iterable is fairly straightforward. These are all the collections like not abstract list, but array list we've seen before, linked list I mentioned, several other options here. But if we scroll down a bit, you'll notice that it has a for each method, which means, okay, no matter what the shape of this collection is, we have the option to shake hands with each item in the collection by simply invoking that for each. And that works out really well because we know what a for each loop is. So no matter what collection we have, we can put it into a for each loop, and each of those items will get processed. Now let's consider some structural patterns. Proxy pattern is an interesting one. We substitute one object for another, but they both implement the same interface, and the proxy controls access to the original object that it's wrapping. So a good example of this is remote computing, which early on was typically how we would communicate from one computer to another. We could have a series of servers, and we could have one kick off a process on another server. This was in the early days, frankly, when, believe it or not, years ago, computers weren't connected. Typically, the output was a printout or maybe something on a floppy disk. But then we started connecting them together and realizing that we can make a call from one to another. And this technology certainly still exists. Currently, the way we would do it is Spring Remoting in Java. And the nice thing about that is you can write a program that lives across different CPUs, across different computers, and it looks like it's running on one same computer. Let's take a look at how that works. So we'll have a user interface here. This could be on a PC or a laptop or a Mac, and that user interface is invoking some behavior locally that's going to go over a network, and then it's going to be essentially reconstituted on the other side, on the server side, and then processed. Now this process here is interesting. This is what we'll call marshalling and unmarshalling, or serializing and deserializing. And what that means is we are taking an object, we're decomposing it to its primitive data types, and then converting that to zeros and ones. We're sending those zeros and ones across the network. Then on the other side, we take those zeros and ones, we convert them back to the primitive types, we take the primitive types, and we convert those back into objects. So, serialization, that's what that process is called. So serialize it into bits and bytes, and then deserialize it back into an object. Also, marshal, that's the synonym essentially. Marshal it into bits and bytes, and then unmarshal it back to an object. Now, the interesting thing is when we're operating on this, when we're programming on this UI, we don't have to worry about any of those details. If we use any of the modern remoting frameworks, like remote method invocation, Spring Remoting, or anything like that, it looks like we're programming against the server, and behind the scenes, remote method invocation or Spring Remoting takes care of all those details. So, user saves something, goes to this class we're going to call a skeleton class. Skeleton class is going to marshal or serialize this item, send it across the network. It's going to be picked up by the stub on the server side. Stub is going to deserialize the object or unmarshalize the object back into an object, and then it might persist it like so. Decorator. Boy, this is an interesting one. This is where we take an object and we wrap it with another object that's providing some added value to that. A good example of this is a really interesting one, which is called aspect-oriented programming, which is available in Spring. And what that does is you can actually change the bytecode of a compiled class after the fact and say, okay, I want to do this before this method is invoked, or do this after this method is invoked, so on and so forth. When this was introduced, a lot of people kind of freaked out, like, what do you mean you can change a class that's already been compiled? And there's a lot of debate. Is this something we really want to do because it feels risky? But there's one really good use case for aspect-oriented programming where most people will agree. Consider this, and I'll go back to my days in point of sale again. You want to save a promotion. Easy enough, right? But what's a promotion made of? Well, it's made of products that apply to the promotion. It's made of rules that say buy one, get one free, limit 4, maximize benefit to the retailer. So in other words, the customer gets for free the least expensive items. It has sets, it has targets, it has rewards. It ends up that a concept as simple as promotion gets stored into several different tables in the database. Now here's the challenge with that. What if we have to store into 4 different tables and one of the transactions or one of the saves, commits, fails and has to be rolled back? Well, do we go ahead and commit to the other 3 tables? Because then we're in an inconsistent state. We really should just abort the entire transaction. And that's where we typically use aspect-oriented programming with Spring. Is what we'll do is we will wrap an AOP, what's called a point cut, right here. And that will kick off a start success unit with a database. Then we'll go down to each of these individual data access objects. Each one represents a table in the database, and we'll save, we'll save, we'll save, we'll save. And provided that none of them throw an exception or fail to commit, then when we exit this method, then boom, we commit the transaction to the database, and it commits universally to all 4 of those tables at once. But if something goes wrong, it's going to throw an exception up here, and we're going to know to not issue a commit, but instead to issue a rollback. So here's what that aspect-oriented programming looks like. And if you're not familiar with Spring, no worries if you don't understand what each of these are. But effectively what we're saying is, on the class called plants and the package com.plantPlaces, and on the method called save, we want to apply transaction advice. So transaction advice is this thing here, and that's the thing that's saying, okay, I want to start a success unit when we enter the save method. I want to commit that success unit when we exit the save method, and do all of the calls that save is delegating to. And if an exception is thrown, then I want to roll that back. So that's kind of an interesting one, but that's a really good use case for aspect-oriented programming in Swing. Adapter. This is an interesting one. They're all interesting, I guess, but allows coordination among objects with different interface. So you have 2 different interfaces, but they're similar, and we need a way to communicate together. Oftentimes, if that's the case, it's worth asking, why are these interfaces different? Are we duplicating data? Do we have multiple data classes that represent the same thing, and we're trying to write some code to wire them together? If so, that's wasted time. And what I would do is say, do we need more than one data object, one data class DTO? Or can we have just one that serves the entire application? My preference would be to have just one and to have one source of the truth. But that being said, let me give you an example, again, from my days in point of sale, where we use this adapter pattern. The point of sale company that I worked for sold to a lot of pharmacies and convenience stores that tended to be open 24 hours a day. And that's a really difficult service level agreement, because that means the point of sale has to run 24/7, 365, and we can never have a time when the point of sale is down, because then we have to lock the front door, and that's really not good for customer service. Now, consider this challenge. What if we have to upgrade the point of sale? Typically, the server is going to be on the same version as the client point of sale devices or cash registers. Well, what if the format of a transaction changes from one to another? So let's take this example where we are upgrading our server and our point of sale devices to version 4.0, and we're going from 3.0. So our 24-hour store, our pharmacy store on Times Square or wherever we are, has 2 registers that have not yet been upgraded, and we've just finished upgrading 2 other registers, and we need to publish all the transactions to the same space so that the store can close its books at the end of the day, or whenever it closes its books. But the problem is we're getting a mix of messages. We're getting the 3.0 and the 4.0. So what we'll do is we'll write an adapter right underneath this server. When it recognizes a 3.0 message, it says, oh, okay, well, I know you're missing these fields from the 4.0 message, so I'm going to go ahead and enhance or augment that, and then I'm going to publish it as a 4.0 message. And that way we kind of have a homogeneous environment where we're receiving these transactions and we're posting them. There is a commercial product, actually it's an open source product, but there is a product called Apache Camel that's really good for doing this type of transaction routing and mapping. That's basically what it's meant for. Now let's take a look at some creational patterns. So builder pattern allows us to build complex objects step by step and allows for different configurations. The analogy that you hear a lot about this is purchasing a vehicle, because you could have a vehicle with, I tend to think old days when like power steering was an option, but now that's standard. So vehicle now with all the cameras all around it and the sensors and the electronic dashboard and heated seats and all of that stuff. So vehicles tend to be complex things to create because there are so many options on it. So builder patterns an analogy for that. I pulled out here an example from an Android project I have in GitHub. And this is how we do single sign-on with something called Firebase authentication. So first of all, what we do is we say, who are our sign-on providers. And nowadays, you go somewhere, you can log on with Facebook, you can log on with Yahoo, your Microsoft account, your Twitter account, whatever. That's what I mean. So it's a two-step process in Android development. We start by saying what are the providers we're going to support. And we have to go through this process of invoking a builder class and then invoking build, which says, okay, create an object out of that. Notice that build is a method, not a constructor. Now we take these objects we've created, we add them to an array. Next thing we do is we take that array and we pass that to, guess what, yet another builder. So we have our auth UI, get instance, create sign-in intent builder, set available providers, and then build. Typically what you'll see in a builder pattern is a chain of method calls like this. And whatever options you want, you just add that method to the chain of calls. So if it were a car, it would be, car builder dot add the heated seats option. Then it might be after that, it might be add a hybrid option, add backup camera, boom, 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 boom. And then when you're finished, you invoke build and it says, okay, what have I been given? Okay, these are the options the user has selected. Boom, here's my object. So that's one that I see a little bit more these days as our applications are getting a bit more complex. Now, that's a look at a lot of my favorite design patterns, but there are a few more that we still have yet to cover. There are a couple I just, for sake of time, I didn't fit into this presentation. There's several more. There's strategy, there's state, abstract factory, several more that I'll let you research on your own. But some of the big design patterns that we'll cover in a separate presentation are the ones that use user interface and data. For many, many years, we used one called Model View Controller, and that one's still common, and it's one that I'll cover in a future video. We now see a few other options there. One's called Model View Presenter and Model View View Model. Model View View Model is frequently used in mobile applications, and that's essentially taking advantage of observables to update the user interface for the user. Now, kind of a funny note on this one. For probably the last 15 years, when I interview a software developer, technical screen, and I've interviewed, I don't know how many, but probably well over 100 at this point, I'm sure. When I interview a software developer, I ask them, what's your favorite design pattern? And there are really about 3 answers to that question. One is, I don't know what a design pattern is. Okay, that's not a good answer. About 15% of people will say that. Next one is Model View Controller. About 70% of people will say Model View Controller because that's typically the first design pattern that people learn, especially when they're doing graphical user interface programming. Now, the last 15% choose something that's not Model View Controller and not, I don't know, a design pattern. They might say command, strategy, factory, whatever it is. Those are the candidates I really want to talk to a lot more because that shows a bit more depth in that I've studied design patterns beyond just the one that I was taught when I was doing graphical user interface programming. And sometimes the candidate will say a pattern that I'm aware of, like factory or command, and I'll say, okay, well, tell me how that works. And, they'll walk through and explain it to me. But then sometimes they'll say a pattern, a design pattern that I've never heard of before. I really like that because then I ask, well, how does that work? And many times I learn a new design pattern. So sometimes the question in an interview will be that obvious, tell me about your favorite design pattern. But other times it might be more subtle, like tell me about good ways to write a program. Or here's a use case, how would you implement this and as a design? So my recommendation to you is to study a few design patterns. You certainly don't need to do all of them, but have maybe 3 or 4 that are really your favorites that you can talk about fluently. And that will help in many situations, not only in interview, but actually in designing and writing code. So as always, I hope this video has been helpful, and I look forward to reading your comments. Thank you.